our final speaker, before I come back and say a few more words, is Katelyn Wells. Katelyn is currently the acting section head of the Clean Transportation team in the Energy and Transportation Directorate of Environment and Climate Change Canada. Her team focuses on decarbonisation and air pollution emission reductions for the marine, rail and aviation sections. Katelyn is also the lead for ECCC on the development of Canada's Arctic Emission Control Area proposal. And Katelyn has a background in atmospheric science and has been working for ECCC for 8 years. Today, she is going to present an overview of some of the work focusing on black carbon from shipping, as well as provide us with an update on Canada's Arctic Emission Control Area proposal. Thank you, Katelyn. The floor is yours.
Great. Thank you so much. And I'll be talking today about a little bit of black carbon work, as well as talking about the emission control area that Andrew mentioned. So this is just an overview, repeating again what I'm presenting on today. So let's start with some of our black carbon research. So Environment Canada, or ECCC is often what I call it because there's so many C's, has 3 main areas where we look at black carbon emissions from shipping in Canada's Arctic. Environment Canada does do a lot of work on black carbon from other emission sources on land in different parts of the country, but I'm focusing today only on what we do related to shipping in Canada's Arctic. First, we look at shipping data and emissions through our marine emissions inventory tool. Some of you may have heard of this tool before, and it's a high-level version is available online. If you were to, there's a clickable link here, but if you were to Google Marine Emissions Inventory Tool, Environment Canada, or Environment Climate Change Canada, you'd be able to come to the landing page. This high level version online is based on a bottom-up activity-based emissions inventory that calculates emissions and scrubber wash water discharge from every vessel that enters Canada's EEZ, or Economic Exclusive Zone. And one of the parameters it's calculates is black carbon, but there is a whole suite of parameters. It calculates heavy metal discharge. It also calculates all the different air pollutants, climate change pollutants, etc. And this is an example of what it will look like online. So this figure is a screenshot of the black carbon emissions in the Arctic from the online tool. And this I've pulled is just 2019. And I don't know if some of you have used this tool, you'll notice that we haven't updated to 2022 yet. We have the data, it's in our database, so we just need to get it online. And so what you'll see here is there are emissions calculated for every location that a vessel is in the Canadian Arctic, or this actually is for all of Canada. And you'll see there's higher points of emissions of black carbon. For example, this is around the Baffinland iron mines. You can see that there's higher shipping traffic there, so we're seeing higher emissions of black carbon. You can also filter the data by province, by ship class, ship types. Let's say you only wanted to know what the merchant bulks were doing. You could then select that. You can look at different date ranges as well. On the online tool, there's a whole bunch of more of these little cards that you can then filter data in different ways. So with that data, when we get all the shipping emissions, there's a lot of research into black carbon that our teams, my team, as well as our science and technology branch and our Meteorological Service of Canada, they do a lot of research on the shipping impacts in the Arctic, as well as the black carbon impacts. And one of the main studies that is at the basis for the ECA proposal, or the Emission Control Area proposal, that I'll get into next, is a multi-year project looking at the impacts of ship emissions on air concentrations and deposition of pollutants in the Canadian Arctic, including black carbon emissions. So this study was published in 2018. Since then, there's been updates that haven't been published, but we've been working with those the different divisions within Environment Canada to get the most recent data for our emissions control area proposal. So I'll highlight a little bit of the results from this study. And this is, complementary to some of the things that Ludmilla was talking about, but we are focusing in directly on Canada rather than the whole Arctic. So like I said, these are from that study. And again, this is a hyperlink here, but this is the name of the study here, assessing the impact of shipping emissions on air pollution in the Canadian Arctic and northern regions, and it's published online. And so these plots show the percent contribution from ship emissions within the Canadian Arctic waters on black carbon deposition. And we're just looking at the main shipping period, or the summer months, July, August, and September. And we're looking at comparing 2010 to two future years, so a business as usual case, and what would happen if we imposed ECA type regulations. Of course, we have data, for this time spanning between 2010 and 2030. So for our emission control area analysis, we've done a lot of digging into what has happened between 2010 and present. And so you'll see here in these two cases, it doesn't look like a lot of reductions, but it is considerable considering just changing a one little regulation. Again, we see a lot of shipping activity that is causing high emissions around the Baffinland area. And in 2010, we didn't quite see that. And so you'll see with an ECA type regulation in place compared to a business as usual, we can see a visible reduction in deposition of black carbon in the Canadian Arctic. So similar to deposition, we also need to look at black carbon in the air column because black carbon not only melts ice, it also warms the air, which can then accelerate warming and melting, as Sean was talking about earlier. So again, these plots are from the same study, and they're showing the percent contribution from ship emissions in the Canadian Arctic waters to the black carbon loading, again, over from July, August, September period. And again, looking at 2010, comparing to a 2030 business as usual and a 2030 emission control area case. So like I mentioned, we've been doing a lot of more research since this has been published, and we're finding that the actual contribution of black carbon emissions from ships is even a little bit higher than we anticipated. So having an ECA in place will show even more reductions than we found in this paper. And that's going to be presented in our ECA proposal, which I'll get into. So as you'll see here, again, the changes by implementing the ECA doesn't visibly, you can't see it as much, but we do look at the data, you can see a pretty big percent reduction in black carbon emissions between these two cases. So the third aspect that our team and our other teams that we work closely with at Environment Canada is we engage at the IMO on black carbon issues. So Transport Canada is our lead for everything at the IMO, but we support on that participation, especially when it comes to technical research or advancing different environment issues related to shipping. And a key area that we are supporting is, as we've been talking about a little bit today, is a Canadian Arctic Emission Control Area proposal. And that's what I'm going to get into next. And so now onto this proposal. So this is a shortened presentation that I normally do about the ECA proposal. And so I'm happy to answer questions after or talk one-on-one as needed. So first of all, looking at a bit of rationale, why are we even considering an emission control area? So first of all, what is an emission control area? And most people here might know this, but an emission control area is a sea area in which stricter controls are established to reduce airborne NOx and SOx emissions from ships. So nitrogen oxides and sulfur oxides. And currently, the Arctic, or the Canadian Arctic, does not have an emission control area, but the rest of North America does. And the North American emission control area stops at 60 degrees north. But in the meantime, we've been seeing shipping increasing in the Arctic, and that means air pollution, and including black carbon emissions and deposition of black carbon from these ships, is also increasing. Increasing pollution has impacts to health and the environment, as Andrew has been talked to earlier. And some of the emissions from vessels also have climate change effects, as we've been talking about today. The whole point of this webinar is looking at the black carbon emissions. Increasing pollution also has impacts to health and the environment. And some of the emissions are, like I mentioned, have the climate change effects. So not only the air quality is important here, but reducing the impacts of climate forcing pollutants. So let's look at a map of the proposal. This is a map showing the North American, or the existing North American emission control area in orange. So you'll see that right here. And then the added purple line here is the proposed Canadian Arctic Emission Control Area boundary. So you'll see where the North American Emission Control Area stops right about here at the very tip of 60 degrees. The proposal will join that, and it will follow the ECA, or sorry, the EEZ boundary, or the marine boundary between Canada and Greenland. And then it goes up and around, and it's approximately 200 nautical miles out, and then it joins the 137th meridian in the Yukon Territory. You'll notice there is an offset here, and the reason for that is there is a well-managed dispute, a marine dispute between Canada and the US in the Beaufort Sea. And so we just need to be cautious of that, and our advice is that we need to go inland a little bit to avoid that dispute at this time. So as I mentioned before, we're seeing an increase in shipping activity in the Arctic. We can look at fuel consumption changes as a marker for emission changes. And albeit that some vessels use different fuels, as Ludmilla talked about. So this graph shows an increase in fuel consumption from 2010 to 2019 in the Canadian Arctic from cruise, merchant, and tanker ships. And you'll see that fuel consumption has more than doubled in the Canadian Arctic, which is indicative of increasing emissions. For emission reductions. So we've looked at the potential emission reductions in 2030 as a result of an emission control area. So this graph shows the emissions in 2019. And I think previously I showed the study that had 2010. So we're kind of combining the information from that study as well as most recent data. And so we're showing 2010 as well as a 2030 business as usual case. So similar to the study I showed earlier, and a 2030 ECA case. So with an ECA, we can see a high reduction of emissions from SOx, or sulfur oxides, total particulate matter, and black carbon here. So while visibly in some of those graphs I showed earlier, you weren't sure how much black carbon reductions we're getting, but some of the calculations we're seeing is it's about a 60% reduction of black carbon emissions from shipping by vessels switching to cleaner fuels in the Canadian Arctic. You'll notice the NOx reductions seem small in comparison, and this is due to the rate of introduction of NOx Tier 3 vessels by the 2030 scenario. The IMO's NOx regulation in an ECA stipulates that a vessel with a keel laid date has a vessel after the date of adoption around there, it will be specified in the proposal, will have to comply with the NOx Tier 3 regulation. So that means any older vessel that is then going into this new ECA wouldn't have to be a NOx Tier 3. And so as more new vessels enter the fleet, you'll see more and more NOx Tier 3 vessels, and then we'll be able to see more NOx reductions as we go further into the future. Okay, so some of the benefits, and I think we've talked a lot about what the benefits are to reducing pollution. Andrew touched to it, as well as others. So I'll just go over them here, specifically in the context of the emission control area proposal. So the ECA has the potential to reduce the warming effects of black carbon should the vessels comply with using cleaner fuels. So anything cleaner than a distillate or cleaner. An ECA would reduce the effects of air pollution, acidification, eutrophication in the Arctic, where critical loads are already being exceeded or exceeded. When sulfur and nitrogen land on the Arctic, there is a really sensitive ecosystem already to the changes in acidification and eutrophication. And so we're finding that adding more pollution to that, the deposition that we're adding to that is then exacerbating a critical load exceedance that we're already seeing. So as we've talked a lot about today, the majority of black carbon particles emitted in the Arctic are from sea level sources within the region, so including ships operating close to areas with snow and ice. So as Sean went over in the beginning, black carbon is accelerating melting of sea ice in the Arctic, and our ice environments in Canada's Arctic remain a critical habitat for a number of species, so including polar bears, walruses, reindeer, narwhals, and many others, as well as the indigenous population. Therefore, increased loss of sea ice in the region results in increased vulnerability to species and that directly depend on the Arctic environments. So Canada recognizes that it has a duty to ensure a healthy environment for all its citizens, not just the ones south of 60. And so on our journey to path of reconciliation with Indigenous people, we have to keep this in mind. So lower ship emissions will reduce impacts to culturally significant areas upon which Indigenous communities depend for their food security, cultural identity, way of life, and health, as Andrew pointed out. Lower ship emissions can help protect vulnerable groups, such as people with pre-existing health conditions, children, older adults, and people with lower socioeconomic status, which can be more sensitive to the adverse health effects of air pollution. So Ludmilla mentioned the HFO ban a little bit. And so one of the questions that we get is, why do we need an ECA and an HFO ban at the same time in the Canadian Arctic? So there's a number of reasons why. The HFO ban is focusing on preventing spills and does not regulate emissions from the combustion of fuels, whereas the ECA is an air pollution reduction measure. Under the HFO ban, there are still options to comply with fuels that don't meet the standards of an ECA, resulting in higher emissions. Vessels are already encouraged to use cleaner fuels in the Arctic, and the ECA would help increase the use of clean fuels and technology in the sensitive area. The HFO ban does not include any regulations on NOx, whereas an ECA does. So this is an update on our timeline. So the ECAs take a long time to designate. So for example, the North American Emission Control Area proposal was submitted in 2009 to the IMO, but it wasn't put into effect until 2013. So we are currently getting close to submission. Right now, we are aiming to submit the proposal in December for the MEPC 81. So that's the meeting that we would like to have the proposal presented at. That meeting happens in March. And so if all goes to plan and we are able to get approval at MEPC 81, then we could potentially get adoption at MEPC 82 at the earliest. And then if we do get adoption, then Canada can start the process, including engagement on the actual legislation, with the goal to have something like this into force in 2027. This 2-year process here, there'll be a lot more engagement. I know Andrew has mentioned that we've been working really closely with different Indigenous groups in the Arctic on the proposal, but the engagement is not over. This whole period here between 2024 and 2026 will include more thorough engagement specifically on how the regulation will look in the Arctic, as well as the aspects of the costs that Andrew mentioned. And that's all I have for you today. This is some contact information should you wish to discuss anything I presented today in further. So again, my name is Katelyn Wells, and I will stop there. Thank you.